these aerial base stations. You can attach them to what we call tether balloons. This is a technology that is based on blimps or airship or aerostat. People call them different ways. Essentially, they take advantage of buoyancy, where basically lighter than air type of gas is filling these type of flying platforms, and they can fly or stay aloft at an altitude of few hundred to couple of kilometers, and they are tethered. So why do you have a tether? You have a tether to supply power to these base stations, and you have a tether that can serve as a backhaul connection to basically connect the network. And you attach a base station to these flying platforms, and you can create your macro cell of few tens of kilometers. So we have done some work on that with one of my former students, Shara, and a few others. Let me skip these technical details. You can find them in the paper, in the slides when you download them from the website. Let's try to keep going higher. So I said that with these tether balloons or tether airships, we can go all the way to few hundred meters to a couple of kilometers. What about if you want to go even higher? Then we hit another interesting emerging technology known as high altitude platform station, or in short HAPS. It happens that actually India is quite active in this area because HAPS can be used for connectivity, but they can be used for many other types of applications. They are also known as high altitude pseudo satellites. So what are these type of interesting new platforms? These are platforms that can come in the form of balloons, airships, and fixed wings, aircraft or gliders. They are there, supposed to be flying at an altitude of roughly 20 kilometers in the stratosphere. Just for information, the airplanes we take to move around are flying at an altitude of roughly 10 to 12, 13 kilometers, so that we are way above the regular airplane. We are in the stratosphere. Okay? Why we are in the stratosphere? Because there is a nice sweet spot there in terms of wind speeds, basically that minimize turbulence. And again, the idea is to attach to these HAPS some base stations and connect people in the ground. Okay? So, this is a typical scenario. You have a HAPS that can be helping some smart agriculture, but it can be also helping a disaster zone that has been impacted by a flood, and simultaneously over a radius of 100 kilometers, you can send multi-beams to basically help different kind of applications, and as on the top of the fact that it can be beyond connectivity, it can be observation, border control, imaging, and so on. Now, of course, the ultimate solution to get the best coverage is to go to space. And here we start talking about a variety of, let's say, space solution in the low Earth orbit, like Starlink, in the medium Earth orbit, like O3b, the other 3 billion, that was the acronym for that, or SES, all the way to the classical, very classical geosatellite, but now the new version of them, they are called the very high frequency satellites. So there is